Good day, everyone. Today we are considering the circle. The circle happens to be one of the conic section. The others are parabola, ellipse, and hyperbola. In this class, we want to look at what the circle is, the equation of the circle, either the circle whose center is at the origin or the circle whose center is not at the origin, the equation of both circles, and how we can know that a given equation is the equation of a circle. Now let's begin by defining what a circle is. The circle is the locus of points equidistant from a given point known as the center of the circle. What this means is that I have a point here known as the center, and every point that has equal distance to this point don't mind my diagram because it's a freehand sketch, give us the circle. So this is it. If I join these points together, I will have something that looks somewhat like this. Don't mind my sketch. Okay, such that the distance from here to here is the same as distance from here to here. Anywhere along this curve give us equal distance. That's the circle actually. This is called the center of the circle, and the distance from here to here is called the radius. Now let's look at equation of a circle. Whose center is the origin. And so such circle looks like this. And this is our x and y. So let's assume that this is a circle. And then the center is here. 0, 0. This is your y. And this is your x. Let's assume that this is a point we are taking whose coordinate is x, y, meaning when chased to the x-axis you have x, and when chased along the y-axis you have y. And remember, the distance from here to that point is known as radius. Then we can tell that the distance along the x here will be x minus 0, and this along the y will be y minus 0. Now, using our Pythagoras theorem, we can say that hypotenuse square is simply equal to opposite square plus adjacent square. Our hypotenuse here is the r square is equal to opposite here can be the x minus 0, which is just x squared, plus the y minus 0, which is just y squared. And this gives us the equation of a circle whose center is the origin. So let's look at the equation of a circle whose center is not the origin. I have a circle here whose center is x1, y1, and this is the origin of this graph. Now, again, let's say I have a point here which is x1, y1, and I want to get the equation of this circle. How would we do that? Well, already, so this x, y, not x, y1. How do we do this? Already, this point here, chase along the x is x1, and here, chase along the x is x. Distance from here will give me x minus x1, and here, chase along the y is y, and here, this point here, chase along the y is y1. So distance from here to here is the same as here to here. This is y minus y1. And this is from here to here is your radius. We can as well say that opposite square, that's Pythagoras theorem, plus adjacent square is equal to hypotenuse square. And so our opposite square can be x minus x1 all squared plus adjacent square is y minus y1 is equal to the radius r squared. Now this can give us this. If we expand this, we are going to have x squared minus 2x x1 plus x1 squared plus, if we expand this, we are going to have y squared plus 2y y1 minus actually, then minus plus y1 squared is equal to r squared. Now we can say this is x squared minus 2x x1 minus 2y y1 is equal to r squared, bringing this to this side, minus x1 squared minus y1 squared is equal to 0. Now we can say that, sorry, there's a mistake here. I omitted, let's write again. I omitted the y squared. So x squared plus y squared, then minus 2x x1 minus 2y y1 is equal to r squared, taking this one here, minus x1 squared minus, taking this one here will be minus y1 squared. And now we can say, let C be equal to r squared minus x1 minus y1. This will give us x squared plus y squared minus 2x x1 minus 2y y1 is equal to C. And this is the equation of our circle. Sometimes some authors go ahead to say, let this not be x comma y, but it should be, and there is center point, so it will not be x1 comma y1, it should be a comma b. Some use f and g, and it will reflect here to be 2gx and 2fy. Changing the x1 to f, changing the y1 to g. Whichever way you want to do it, you can still take this as we've gotten here. It doesn't change anything at all, at all, at all. And so this is the equation of a circle whose center is x1 comma y1. So let's look at the properties of the equation of a circle. One, it is a second degree equation in x and y, meaning that if you look at each of these, either the center is at the origin or not, it has x being raised to power 2 and y being raised to power 2. X raised to power 2 and y raised to power 2. So it's a second degree equation in x and y. Next, it has the coefficient of x squared and y squared being equal. If you look at here, the coefficient of x squared is 1, coefficient of y squared is 1. Coefficient of x squared is 1, coefficient of y squared is 1. If this is coefficient of x squared is 2 here, the coefficient of y squared should also be 2. The coefficient of x squared and y squared are the same. And lastly, it has no x, y term. You can't see xy here, neither can you see xy in the equation of a circle. Now let's take example on this. Example 1, find the equation of a circle whose center is the origin and radius is 5 cm. Solution. Here, the center is the origin, so our equation should look like this: x squared plus y squared is equal to r squared. And then we are giving our r to be 5 cm. So this is x squared plus y squared is equal to 5 squared. And that's x squared plus y squared is equal to 25. That's the equation of this circle. Example 2. Find the equation of the circle whose center is 3, minus 2 and the radius is 2 units. Now to solve this question, we have our center 3, 2. 3, minus 2, that's your x1, 3, and y1 as minus 2. And the radius is 2 units. And so from the equation we have it as x squared plus y squared plus or minus 2x x1 minus 2y y1 equal to c. And so we can say our c is equal to r squared minus x1 minus y1 all squared. And so, how do we get this now? We are given our radius. That's 2 squared minus our x1 is 3 squared minus our y1 is minus 2 squared. This will give us 4 minus 9 minus 4. And that will give us minus 9. And so we have this to be x squared plus y squared minus 2x into our x1 is 3 minus 2y into our y1 is minus 2 is equal to c. So this will give us x squared plus y squared minus 6x minus or plus 4y is equal to minus 9. You can bring the minus 9 inside and that will give you x squared plus y squared minus 6x plus 4y is equal to 9. Plus 9 is equal to 0. And that's all. There's a second way to solve this actually, but let's forgo that here. Example 3, find the equation of the circle whose center is 5, minus 4 and passes through minus 3, 2. Now, let me sketch this. This is a circle. The center is 5, minus 4. So this is our x1 and this is y1. Now it passes through that point, and that point is minus 3, 2. Why do we need this? I need to get the distance between these 2 points. So I'm using distance between 2 points. I can call this my x2, y2. And we say distance, whatever this point is, let's say this point is point A and point B. Distance AB is actually our radius. And we need the radius and the center to get the equation. So this is going to be square root, distance between 2 points. That's what we're using here. x2 minus x1 all squared plus y2 minus y1 all squared, all into square roots. This is going to be s2 is minus 3 minus x1 is 5 squared plus y2 is 2 minus y1 is minus 4 squared as well. This is going to give us minus 8 squared plus minus 8 all squared plus 2, this will be 2 plus 6, 2 plus 4, that's 6 squared. And so we can say our AB, which is our radius, is actually equal to square root of 64 plus 36. And that will give us square root of 100, which is 10. So I've gotten my radius to be 10. Now, let's proceed. Rubbing off this now. We've got our radius and we have our center. We can now say, since our x1 is known, which is 5, and y1 is minus 4, we can say our equation of the circle is given as x squared plus y squared minus 2x x1 minus 2y y1 minus is equal to c. Okay? So here, let's get our c. Our c is r squared minus x1 squared minus y1 squared. Our r is given as 10, so 10 squared minus our x1 here is 5 squared minus our y1 is minus 4 squared. And this is giving us 100 minus 25 minus 16. And that will give us 100 minus 41, which is 59. That's our c. So we can say our equation becomes x squared plus y squared minus 2x into our x1 is 5 minus 2y into our y1 is minus 4 is equal to our c, which is 59. So this will become x squared plus y squared minus 10x plus 8y is equal to 59. And you can bring the 59 inside, become minus 59, or you can stop here. So that's that for this example. Example 4, Find the center, radius, and radius of a circle whose equation is x squared plus y squared minus 6x plus 4y minus 3 equals 0. To solve this, I'm going to say this is equal to solution. This will be x squared plus y squared minus 6x plus 4y equals 3. Then we compare with x squared plus y squared minus 2x1 minus 2x 2y y1 is equal to c. From this we can say this compared to this, everything that have x will what have x, and that will give us, comparing the x alone here, that will be minus 2x x1 is equal to minus 6x. Now cancelling, dividing both sides by x, eliminate this x, and dividing both sides also by minus 2. Minus cancel minus and 2 cancel 2. You are left with x1 is equal to minus cancel minus 6 over 2, that's 3. Again, comparing our y alone, y and y, that will be, we can say minus 2y1 is equal to 4y. Now divide there by minus 2y, divide there by minus 2y. Y eliminates y, and minus 2 eliminate minus 2. Again, that y1 is equal to, y cancels y, and minus 2 in 4 give us minus 2. Got our x1 and y1. Again, we can compare again. C is actually 3. And remember how we got our c. C, which is r squared minus x1 squared minus y1 squared is equal to 3. That was c is. So we're looking for our r now. We know our x1. Our x1 we got to be 3 squared minus our y1 we got to be minus 2 is equal to 3. So we can say our r squared is equal to 3. Bringing this here will give us, or let's simplify for the first, that will be minus 9 minus 4 is equal to 3. This will be r squared is equal to 3 plus 4 and plus 9. That gives us r squared is equal to 16. And then r is square root of 16. And that's 4. And so we've gotten our r and our x1 and y1. Now we have to get the center. Center is x1, y1. And that will be our center, x1. We got that to be 3. And y1, we got that to be minus 2. That's the center. And the radius is simply equal to 4. So that's that for this question.